In this final recording, I'm going to walk us through a few more examples, but in these cases, we're going to go back the other direction. On each of our properties that we covered earlier, we were able to take a logarithm and expand it. So, for example, if I had log of an xy, it became log of x plus log of y. The reason I write that up here is to say we went this direction in the previous examples. Now we're going to go this way. If you see a sum, you can turn it into a single logarithm as a product, which is exactly what I'm going to do on this example right here. I'm going to take log base 4 of 2, and since it says write each logarithm as a logarithm of a single expression, in other words, combine, then I'm going to take these two that are added together, two separate logs but the same base, are added together. I'm going to multiply their insides. This is the same thing as log base 4 of 2 times 32, which is 64. And you can see how that helps us in this case, where I couldn't take log base 2 of 2 without a calculator, log base 4 of 2 without a calculator, or log base 4 of 32 without a calculator. I can do log base 4 of 64. That's just 3. Because 4 raised to the third is 64. That's your final answer. And all of your properties can work in reverse. So I can take that 1/2 that's out front on this next one and move it up into the exponent. I can take that 4 and move it up into the exponent, and this becomes log of x to the 1/2 plus log of x minus 1 all to the 4th power. Then I can take the product rule that says when I have a plus sign inside, I can then multiply the insides of the log and write that as a single log, log of x to the 1/2 times x minus 1 to the 4th. Now I'm going to go ahead and rewrite, in this case, my x to the 1/2 as square root of x, although I don't have to. That is my final answer on that problem. Notice how that is a single logarithm. So you can move coefficients outside, up, inside. You can combine when they're just a log added to a log. Notice I can't add them into a single log until the only thing in front is log. Right? I couldn't combine these together until I moved those powers inside. Then I can apply the log of a number plus the log of the number is the log of the product. That rule I can apply only when there's no number out front of the log. Alright, I got 2 more examples and then we'll be done. Again, we're going to do the same thing we did before. I am going to pull that 3 up inside. I'm going to pull this 6 up inside on the second one, right here, and I'll have minus natural log of x to the 6th, and there's nothing I'm going to do with that 8. I'm just going to leave it there. So now what I recognize is that these two terms are both added. They're both positive, which means I can write it as the log of those multiplied together. I'm just going to switch the order so the 8's out front, but it doesn't matter. I'm going to put the 8 times x plus y raised to the 3rd. And then this one's subtracted, and when you subtract a log where it's the same log, you divide by it. So it's over x to the 6th. So again, remember, if you had natural log of a plus natural log of b, that's natural log of a times b. If you had natural log of a minus natural log of c, that's when you get natural log of a over c. So if I had both of those in there, like a natural log of a minus natural log of c plus natural log of b, that's where I get natural log of a times b on top and a c on bottom. It's exactly how we got that answer right there. So on the last example, we're going to move all of my powers inside. So use the power rule on this 2, on this 6, and then inside the parentheses, I'm going to combine those like I would these up here. Since it's added here, I'm going to multiply the insides of these 2 logs, and then since this one's subtracted, I'm going to divide. So step by step, it looks like this. I'm going to do inside the parentheses first and do the 3 at the end. So move that 2 in here and move that 6 in here, and what you get is log base 5 of x plus log base 5 of y squared minus log base 5 of z to the 6th. So inside, I can take the two that are added together and multiply, and take the one that's subtracted and divide, and it looks like this. 3 times log base 5 of x times y squared divided by z to the 6th. But now to finish this, I'm going to take this 3 out front and move it inside and make it a power of the whole inside expression of the logarithm. So that's log base 5 of xy squared over z to the 6th, all raised to the 3rd. Which is actually a fine answer, but you can also, if you chose to do it, you could take this 3 and raise everything inside here to the 3rd power and write it as log base 5 of x to the 3rd, y to the 6th over z to the 18th. Either one of those is correct, this one or this one. And that's the end of section 16.2. So you should have all the skills now you need. You take these practice problems and go work the homework in section 16.2. Thank you very much, and you're done.